Welcome back, and in this video I want to cover the differences between stateful and stateless firewalls. And to do that I need to refresh your knowledge of how TCP and IP function. So let's just jump in and get started. In the networking fundamentals videos I talked about how TCP and IP worked together. You might already know this if you have networking experience in the real world, but when you make a connection using TCP, what's actually happening is that each side is sending IP packets to each other. These IP packets have a source and destination IP and are carried across local networks and the public internet. Now TCP is a layer 4 protocol which runs on top of IP. It adds error correction together with the idea of ports. So HTTP runs on TCP port 80 and HTTPS runs on TCP port 443 and so on. So keep that in mind as we continue talking about the state of connections. So let's say that we have a user here on the left, Bob, and he's connecting to the Catagram application running on a server on the right. What most people imagine in this scenario is a single connection between Bob's laptop and the server. So Bob's connecting to TCP port 443 on the server, and in doing so he gets information back. In this case, many different cat images. Now you know that below the surface at layer 3 this single connection is handled by exchanging packets between the source and the destination. Conceptually though, you can imagine that each connection, in this case it's an outgoing connection from Bob's laptop to the server, each one of these is actually made up of two different parts. First we've got the request part where the client requests some information from a server, in this case some cat images, and then we have the response part where that data is returned to the client. Now these are both parts of the same interaction between the client and server, but strictly speaking you can think of these as two different components. What actually happens as part of this connection setup is this. First, the client picks a temporary port, and this is known as an ephemeral port. Now typically this port has a value between 1024 and 65535, but this range is dependent on the operating system which Bob's laptop is using. Then once this ephemeral port is chosen, the client initiates a connection to the server using a well-known port number. Now a well-known port number is a port number which is typically associated with one specific popular application or protocol. In this case, TCP port 443 is HTTPS. So this is the request part of the connection. It's a stream of data to the server. You're asking for something, some cat pictures or a web page. Next, the server responds back with the actual data. The server connects back to the source IP of the request part, in this case Bob's laptop, and it connects to the source port of the request part, which is the ephemeral port which Bob's laptop has chosen. This part is known as the response, so the request is from Bob's laptop using an ephemeral port to a server using a well-known port. The response is from the server on that well-known port to Bob's laptop on the ephemeral port. Now it's these values which uniquely identify a single connection. So that's a source port and source IP, and a destination IP and a destination port. Now I hope that this makes sense so far. If not, then you need to repeat this first part of the video again, because this is really important to understand. If it does make sense, then let's carry on. Now let's look at this example in a little bit more detail. This is the same connection that we looked at on the previous screen. We have Bob's laptop on the left and the Catagram server on the right. Obviously the left is the client and the right is the server. I also introduced the correct terms on the previous screen, so request and response. So the first part is the client talking to the server asking for something, and that's the request, and the second part is the server responding, and that's the response. But what I want to get you used to is that the directionality depends on your perspective, and let me explain what I mean. So in this case, the client initiates the request, and I've added the IP addresses on here for both the client and the server. So what this means is that packets will be sent from the client to the server, and these will be flowing from left to right. These packets are going to have a source IP address of 119.18.36.73, which is the IP address of the client, so Bob's laptop, and they will have a destination IP of 1.3.3.7, which is the IP address of the server. Now, the source port will be a temporary or ephemeral port chosen by the client, and the destination port will be a well-known port. In this case, we're using HTTPS, so TCP port 443. Now, if I challenge you to take a quick guess, would you say that this request is outbound or inbound? If you had to define a firewall rule right now, would you pick inbound or outbound? Well, this is actually a trick question because it's both. From the client perspective, this request is an outbound connection. So if you're adding a firewall rule on the client, you would be looking to allow or deny an outbound connection. From the server perspective, though, it's an inbound connection. So you have to think about perspective when you're working with firewalls. But then we have the response part from the server through to the client. This will also be a collection of packets moving from right to left. This time, the source IP on those packets will be 1.3.3.7, which is the IP address of the server. The destination IP will be 119.18.36.73, which is the IP address of the client, so Bob's laptop. The source port will be TCP port 443, which is the well-known port for HTTPS, and the destination port will be the ephemeral port chosen originally by the client. Now again, I want you to think about the directionality of this component of the communication. Is it outbound or inbound? Well, again, it depends on perspective. The server sees it as an outbound connection from the server to the client, and the client sees it as an inbound connection from the server to itself. Now, this is really important because there are two things to think about when dealing with firewall rules. The first is that each connection between a client and a server has two components, the request and the response. So the request is from a client to a server and the response is from a server to a client. The response is always the inverse direction to the request, but the direction of the request isn't always outbound and isn't always inbound. It depends on what that data is together with your perspective, and that's what I want to talk about a bit more on the next screen. Let's look at this more complex example. We still have Bob and his laptop and the catagram server, but now we have a software update server on the bottom left. Now, the catagram server is inside a subnet which is protected by a firewall, and specifically this is a stateless firewall. A stateless firewall means that it doesn't understand the state of connections. What this means is that it sees the request connection from Bob's laptop to catagram and the response, so from catagram to Bob's laptop, as two individual parts. You need to think about allowing or denying them as two parts. You need two rules. In this case, one inbound rule, which is the request, and one outbound rule for the response. This is obviously more management overhead, two rules needed for each thing which you as a human see as one connection. But it gets slightly more confusing than that. For connections to the catagram server, so for example when Bob's laptop is making a request, then that request is inbound to the catagram server. The response, logically enough, is outbound, sending data back to Bob's laptop, but it's possible to have the inverse. Consider the situation where the catagram server is performing software updates. Well, in this situation, the request will be from the catagram server to the software update server, so outbound, and the response will be from the software update server to the catagram server, so this is inbound. So when you're thinking about this, start with the request. Is the request coming to you or going to somewhere else? The response will always be in the reverse direction. So this situation also requires two firewall rules, one outbound for the request and one inbound for the response. Now there are two really important points I want to make about stateless firewalls. First, for any servers where they accept connections and where they initiate connections, and this is common with web servers which need to accept connections from clients but where they also need to do software updates. In this situation you'll have to deal with two rules for each of these, and they will need to be the inverse of each other. So get used to thinking that outbound rules can be both the request and the response, and inbound rules can also be the request and the response. It's initially confusing, but just remember, start by determining the direction of the request, and then always keep in mind that with stateless firewalls you're going to need an inverse rule for the response. Now the second important thing is that the request component is always going to be to a well-known port. If you're managing the firewall for the catagram application, you'll need to allow connections to TCP port 443. The response though is always from the server to a client, but this always uses a random ephemeral port. Because the firewall is stateless, it has no way of knowing which specific port is used for the response, so you'll often have to allow the full range of ephemeral ports to any destination. This makes security engineers uneasy, which is why stateful firewalls, which I'll be talking about next, are much better. Just focus on these two key elements, that every connection has a request and a response, and together with those keep in mind the fact that they can both be in either direction. So a request can be inbound or outbound, and a response will always be the inverse to the directionality of the request. Also, you'll need to keep in mind that any rules that you create for the response will need to often allow the full range of ephemeral ports. That's not a problem with stateful firewalls, which I want to cover next. So we're going to use the same architecture. We've got Bob's laptop on the top left, the catagram server on the middle right, and the software update server on the bottom left. A stateful firewall is intelligent enough to identify the response for a given request. Since the ports and IPs are the same, it can link one to the other, and this means that for a specific request to catagram from Bob's laptop to the server, the firewall automatically knows which data is the response. And the same is true for software updates. For a given connection to a software update server, the request, the firewall is smart enough to be able to see the response, so the return data from the software update server back to the catagram server. And this means that with a stateful firewall, you'll generally only have to allow the request or not, and the response will be allowed or not automatically. This significantly reduces the admin overhead and the chance for mistakes, because you just have to think in terms of the directionality and the IPs and ports of the request, and it handles everything else. In addition, you don't need to allow the full ephemeral port range because the firewall can identify which port is being used and implicitly allow it based on it being the response to a request that you allow. Okay, so that's how stateless and stateful firewalls work. I know it's been a little bit abstract, but this has been intentional because I want you to understand how they work conceptually before I go into more detail with regards to how AWS implements both of these different security firewall standards. Now at this point, I've finished with the abstract description, so go ahead and finish this video, and when you're ready, I'll look forward to you joining me in the next.